visiting one of the most scenic places in San Diego, it's easy to gain a sense of peace and serenity. The waves and caves of La Jolla conceal a mystery from our eyes until we look closer at the surrounding flora and fauna. Let's take a second look at the La Jolla Historical Society with an art exhibit titled Order, Disorder, Belonging in Nature. It reveals the connection we have with the unique environment of our life-giving planet, as well as the plants and animals we share it with. The color blue signifies the sky we see encircling Earth, or the water which covers 71% of our planet. Both are vital to survival for almost all living things. In the artwork here, we see giant reeds arranged in the shape of Earth and cut to outline blades of renegade weeds growing. They have the ability to grow in the harshest of conditions, and yet our planet seems to be the only one in the universe with life. The giant reed, known as Arundodonax, is an invasive plant that occasionally spreads around La Jolla's coastal walk. It can grow up to 20 or 30 feet high if left alone. Although they are unwanted in scenic areas like the Children's Pool and La Jolla Cove, Arundodonax has been the material of choice for woodwind instrument reeds. Reeds are thin wooden pieces placed onto the mouthpiece of a clarinet or saxophone, or inserted into an oboe or bassoon. The reed vibrates with air blown from the musician, moving the air column within the woodwind to produce musical sound. Synthetic materials are also used, but natural Arundodonax is still predominant for its superior performance and sound quality. Another circular art piece shows what appears to be the Earth rising and eclipsing another heavenly body. This one is titled Biosphere and suggests the importance of the ecosystem on our little blue planet. How rare is the biosphere of our Earth? In all the known universe, there is a very conservative estimate of 100 billion galaxies. In our own Milky Way galaxy, NASA estimates 100 billion planets. The number of galaxies multiplied by the number of planets in each yield an estimated total of 10 sextillion planets in existence. If the Earth is the only living biosphere within the known universe, the infinitesimally small chance of this occurrence can be understood with a rough analogy we can grasp numerically in terms of the Powerball lottery. To win the grand prize, the odds are approximately 1 in 292 million. Now imagine buying over 34.2 trillion Powerball tickets where every ticket is a guaranteed loser, except for the last ticket, which still only gives you a 1 in 292 million chance to win. This is how rare the Earth is, if it's truly the only planet with life. So you see, if our Earth is the only one habitable by life, we must do everything in our power to prolong its existence and maintain the precious biosphere which respirates us with the air we breathe, quenches our thirst with the water we drink, and nourishes our hunger with the food we eat. Eventually, our very sun that provides life-giving heat and warmth will inevitably die, becoming a red giant and will engulf the Earth. Long before that, our Earth is predicted to stay habitable for another 1.3 billion years, as long as we humans take care of the environment and don't do anything foolish like prematurely ending all life as we know it. We are in the initial stages of considering habitation of the Moon and other planets like Mars. Missions are scheduled to return to the Moon in a few years and land people on Mars by the next decade. NASA is already conducting year-long analog tests for Mars, with 4-member crews isolated in a 3D printed 1,700 square foot habitat. For us to survive with a little more comfort and freedom, we must bring with us the Earth's biosphere that is so vital to our existence. In the early 1990s, an experiment titled Biosphere 2 was conducted in Oracle, Arizona. The name derived from the effort to replicate the efficiency of Biosphere 1, or Planet Earth. It was a 2-year mission where a crew of 8 was to survive in an enclosed system to simulate life on other planets. The experiment included a rainforest, an ocean with coral reef, mangrove wetlands, a fog desert, savanna grasslands, an agricultural system, labs, and a human habitat. Biosphere 2 was only used twice for its intended mission. Unfortunately, both attempts failed. Low food and oxygen levels affected the crew. Plants and animals died, creating unexpected challenges. Disagreements broke the crew into 2 factions, although they did work together to maintain the environment and survivability of the biosphere itself. Part of the Scientific Advisory Committee resigned, and new management defeated the whole purpose of having an enclosed system by allowing transfer of samples and equipment into and out of the airlocks. Some information like healthier diets and achievable food sustainability was gathered, but it also revealed the details and challenges of perpetuating an Earth-like biosphere. Over 3 decades later, Biosphere 2 is currently run by the University of Arizona as a research facility with tours open to the public. The simplicity of life in our oceans often provides inspiration for artwork based on their natural tendency to produce repetitive patterns. Why is this? Seaweed, for example, optimize their growth to take in as much sunlight as possible for photosynthesis. Here's a piece made from mixed lichen showing the sunset, the source of energy for sea plants to produce food. Some seaweed can grow almost 900 feet below the ocean's surface, a depth where barely any sunlight can reach. Radial symmetry can be seen in jellyfish, sea stars, and sea urchins. It enables capture of food from all directions and requires less energy. However, it limits an organism to slower movement and weaker defense against predators. This piece is named Stingray and implies the bilateral symmetry shown by most aquatic life. Because we humans are bilateral, it permits focus of movement in a forward direction, allowing for hunting of food and escaping danger. This artwork is called Double Phi Vortex 2, referencing the Greek letter phi, which stands for the golden ratio, which we'll explain in a bit. One look and you can see a pattern emerge. The question is, do you see this pattern spiral clockwise or counterclockwise? The answer is both. How can this be? Why is it of importance? And how does it relate to life in the ocean or our planet Earth in general? For this, we need to retrace back in time over 8 centuries to medieval Italy in the year 1202. Mathematician Leonardo of Pisa wrote a book of calculation titled Liber Abaci, which explain the Hindu-Arabic numeral system, the most common base 10 decimal system used today. One of the problems presented in the book involves how to solve population growth of rabbits, starting with one pair. Here's a page from the Liber Abaci, with a sequence of numbers on the right side that show the generational numbers of pairs. This sequence was first described in 200 BC in Indian mathematics and is named after Leonardo of Pisa by his more popular name of Fibonacci. These are numbers of the Fibonacci sequence. It starts with 0 and 1, and each subsequent number is calculated by adding the previous two together. 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13. From there, the addition of adjacent numbers produce 21, 34, 55, 89, 144, and so on. The Fibonacci sequence is significant because it appears in music, nature, meteorology, astronomy, and other applications. Looking at a piano keyboard, we see 2 black keys with another 3 grouped to the right. There are 5 black keys altogether, and 8 white keys in an octave. The total number of keys in an octave is 13. It may be coincidence, but these are all numbers found in the Fibonacci sequence. Here are squares of the Fibonacci sequence arranged next to each other. From the center, the values of their sides are 1, 1, 2, 3, 5, 8, 13, and 21. If we draw a curved line connecting opposite corners of each square, we get a spiral based on the Fibonacci sequence. This spiral can be found in the shell of the nautilus, an ancient mollusk that has existed for 480 million years. Within the spiral-shaped shell are chambers used to control buoyancy. At the La Jolla Historical Society is an art piece called Herbed Nautilus that shows the spiral of the Fibonacci sequence. Following from the center outward, the crescent-shaped sections become larger and larger. Although not exactly the same, the Fibonacci spiral closely resembles a particular logarithmic spiral called the golden spiral. If we look at the surface of a pine cone or the center section of a large sunflower, spirals radiate outward from the center in both directions. When you count the number of spirals in opposite directions, they equal adjacent numbers in the Fibonacci sequence. The example here shows 34 spirals one way and 21 in the other direction. These numbers are next to each other in the Fibonacci sequence. When viewed from the International Space Station, hurricanes have the shape of the golden spiral, from the eye wall near the center to the outermost rain bands. Even spiral galaxies, like our own Milky Way galaxy, exhibit similar proportions over the vastness of space. Here we see our Sun floating almost insignificantly, circled as a tiny dot on a partial arm called the Orion Spur. Keep in mind, there are at least 100 billion galaxies just like this one in existence. The golden spiral gets wider by a factor called the golden ratio for every quarter turn it makes. The golden ratio can be closely approximated by using 2 adjacent numbers in the Fibonacci sequence. If we divide 8 by 5, we get 1.6. 2 numbers further up the sequence yield a closer approximation to the golden ratio. So 233 divided by 144 gives us 1.618. Continuing this division with greater numbers will sometimes be above or below, but never equal to the irrational golden ratio. What is the significance of the golden ratio? As with the Fibonacci sequence, the golden ratio is present in architecture, nature, and even economics. The Great Pyramid of Giza, which houses the tomb of King Khufu, has a connection with the golden ratio. If we divide half of the base length by the slant height of one of the faces, we get the inverse of the golden ratio, which happens to be itself -1. The golden ratio is the only positive number whose reciprocal equals itself -1. The arrangement of leaves when they grow, also known as phyllotaxis, will often follow the golden ratio for their spiral patterns, as it allows for optimal gathering of sunlight for photosynthesis with minimal overlap. The golden ratio, somewhat surprisingly, is used in the human-made institution of the stock market, something far from nature and even more digital than physical. As an example, here is a graph showing Microsoft stock. The price moves up and down vertically while time progresses from left to right. One of the tools used to predict price movement is called a Fibonacci retracement. When the highest level is selected here in July 2023, and the lowest level is selected in January 2023, a blue area with a percent scale on the right appears. Notice how the price moved from 0% all the way up to 100%, then retraced itself back down to 61.8%. This 61.8% is 0.618 in decimal form, also known as the inverse of the golden ratio. In this case, the Fibonacci retracement appears to predict exactly where the price will bounce back up. Unfortunately, that's not always the case. In fact, if you can imagine millions of people using the same tool with the same idea, it becomes a self-fulfilling prophecy. Maybe it's more a measure of herd mentality than stock price prediction, but nevertheless an interesting application of the Fibonacci sequence and the golden ratio. Outside the window, we can see the ocean just a few blocks away. On the wall inside are the fragmented stories of the La Jolla Caves. Little pieces of other people's lives found nearby on the shore. Mementos that were intentionally discarded, or keepsakes that were unintentionally lost. Each photo or object doesn't tell a complete story, but rather a small portion of a whole. When we think of our own lives and the memories we carry, aren't they just the same? In other words, we remember things that are novel or exciting, and tend to forget others that are tedious or monotonous. In the handful of decades we exist on this planet, time passes slowly when we're young and appears to accelerate as we age. Why is this? What exactly is time? And why do we only recall certain parts and forget others? Time is the continued progression of existence and events from the past through the present and into the future. It's definitely more than what can be defined in a single sentence. Time allows a picture to become a video, a note or chord to become an arpeggio or song, or a pose or posture to become a dance. In order to tell time, obelisks were built by ancient Egyptian cultures in 3500 BC to track the shadow cast by the sun. By 1500 BC, timekeeping devices like the sundial were used in Egypt and Babylonia. The prominent triangular gnomon would point to the hour of the day. Shortly thereafter, water clocks were developed and could tell time when sunlight was not available. These inflow or outflow designs relied on gravity to fill or empty a vessel, marked inside to indicate the passage of time. The convention of 24 hours in a day, 60 minutes in an hour, and 60 seconds in a minute were shaped over many centuries of cultural influence. In ancient Egypt, sundials and stars divided each day into 12 equal segments of daylight and 12 equal segments of night. As we know now, there is more daylight during certain parts of the year and more night during other parts. This led to variable lengths of segments throughout the year. But when working a field for agriculture or performing religious prayer at sunrise or sunset, the pattern of day and night was more important than the concept of a rigid, consistent hour. The value of 60 was the numerical base used by ancient Sumerians and Babylonians, and was likely chosen for minutes and seconds because of its abundance of divisors, making it easy to work with fractions. Early in the 20th century, Albert Einstein's special and general theory of relativity said the rate at which time passes depends on your frame of reference. Without getting into too much of the mathematics, here's an example. A group of astronauts are leaving Earth on an 8.8 light-year round-trip visit to our closest star system, Alpha Centauri. Right before they leave, 2 babies are born on that day. One travels with the crew on the spaceship, which somehow achieves a cruising velocity of 99% the speed of light, while the other baby stays with its family here on Earth, awaiting the return of the spaceship. Because of the time dilation explained by Einstein's theory of relativity, people in motion at greater speed will experience the passage of time more slowly. Upon returning to Earth, the baby on the spaceship is now almost 9 years old, whereas the baby who remained on the planet will now be over 62 years old. To a much lesser degree, astronauts that have spent extended periods of time on the International Space Station have slowed their biological clocks by a handful of milliseconds compared with the rest of us. None of us travel at the speed of light, but most of us become more sedentary and move less rapidly as we age. Perhaps this may explain why time seems to accelerate as we get older. Settling into routines and familiarity, we observe time compresses itself into smaller and smaller fragments of the days, months, and years we have spent in existence. We spend time thinking about the past and things we may have done differently to reconcile a regret or change our current situation. A crucial mistake we've made, something we might have said or didn't say. What if I had done this? Or what if I had done that? We spend time thinking about the future and how our actions may influence incidents or events that have yet to occur. Having a goal or a vision of where you want to be is a worthy endeavor, but it will remain just a fantasy or a daydream if no action is taken in the present. The time we stay focused in the present helps us to be mindful of our own existence as well as the world around us. Whether it's experiencing nature outside, creating art or music, writing in a journal every day, or setting aside a few minutes for breathing and meditation, living life in the present helps us to mend together the fragmented stories of ourselves. Consider the fragments in your life and how you can make them whole again. Sometimes all it takes is viewing the horizon outside your window. If you enjoyed this video and all the original music, help this channel grow for free. Leave a comment below, click like, share this video and channel with others, and click the button to subscribe. Thanks for watching San Diego Review.